Hi folks, OCA here. Summary of this video in one sentence. It's an easy to follow tutorial to create the ultimate Audyssey calibration. Not only it will eliminate all the suboptimal Audyssey adjustments like steep high frequency roll-off, excessive dynamic EQ surround speaker boost, inaccurate speaker distance and inaccurate crossover settings, but also it will keep dynamic EQ on and benefit from its potential to keep responses at target level at different volume levels. The only requirement is the MultEQ Editor app, hence the total cost of the whole process is $20. We don't need MultEQ-X, but MultEQ-X users can also easily implement the method. Here is my full Atmos system response with no correction versus after XT32 Audyssey calibration with all default settings, dynamic EQ on, 0 dB reference level, dynamic volume medium strength, mid-range compensation on for all speakers and all distances and crossovers as Audyssey decided. Graphs were produced from REW measurements with a calibrated U-Mic-2 microphone after applying 15 cycles frequency-dependent windowing and psychoacoustic smoothing. All speakers have this steep roll-off starting from at around 12-13 kHz going all the way down. Mid frequencies are overdimmed, especially in the main speakers. Since graph scales are equal, it's clear that Audyssey calibration applies an overall boost like this much to all speakers, and it seems on top of that the EQ has boosted the volume of height speakers here by around 5 dB and surround speakers by another 5 dB. The highest volume I watch movies in my system is around -25 dBFS, which is 75 dB. Reference level used in Studio Masters is -20 dBFS, 85 dB. 85 dB isn't rock concert loud, but it's still more than double the volume where I listen, and a bit higher than most people at home will naturally crank their sound. Dynamic EQ will keep applying the boost up to 0 dBFS, okay? And 0 dBFS has 200 times more sound energy and more than 3 times louder than 85 dB reference level, and will quickly cause permanent hearing loss if you're exposed to it. It's hard to understand Audyssey's choice to hold dynamic EQ boost all the way up to that level. When comparing filters, we tend to think the louder filter is better for the first few seconds, so maybe excessive loudness is an Audyssey trick to make an impression. Anyway, I guess it's fair to say that other than tidying up the bass response below 200 Hz a little bit, the overall result is worse than the uncalibrated default room response. Now is a comparison with the results of the method we will implement in this video with Audyssey. The graphic scales are again equal. The tiny peaks here in fact are not even present. They're caused by the dirty electricity 50 Hz hum in this apartment. The speakers are all crossed over above 50 Hz, so the response here should only be the subwoofer response, but every measurement depending on the phase at 50 Hz get different responses, so there is no peak here. You can be certain of that. This is not a calibration error. But look at the difference. Another comparison at large scale from 20 to 20 kHz audible range between my method and Audyssey's correction. You can see the exact boosts of the surrounds and the heights and the mains more clearly. The total boost compared to my correction. These are from the same speakers at the same volume level of the receiver, everything the same. This target curve is derived from the Harman target curve. Is the most preferred response when factors like frequency-dependent windowing, psychoacoustic smoothing and reference level volume are taken into account. It becomes this straight slope. There is more information here if you're interested. If you don't have a calibrated microphone, you can use Audyssey's standard microphone that comes with your receivers. I will provide the calibration file Audyssey batch applies to them. I derived it by comparing an Audyssey measurement hacked from the app with a REW measurement for the same speaker with the same microphone, which was not moved between measurements. And as you can see, most of the response is identical, so it's accurate. You will need to upload this calibration file, which I will provide, into REW as MIG calibration file before taking measurements. Then you'll be able to apply this method and still get remarkably better results than your previous attempts, but obviously a calibrated microphone should be preferred. So now let's start. First you need to transfer an unedited original MultEQ Editor app measurement file .ady to your PC. If you don't have one, the quickest way is to run Audyssey measurement from the app and end it after just 3 measurements, the minimum required. You don't have to move the Audyssey microphone during these measurements, nor do they have to be taken at the central listening position. This is just the dummy ADY file we will use as a base for our correction. We will not use Audyssey measurements. Just make sure amp assignment and speaker detection are correct, mid-range range compensation is off for all channels. Sending and receiving ADY measurement files between your PC and phone is pretty straightforward, but if you don't know how to do it, you can find instructions in my previous videos. When you have the ADY file in your PC, here mine original.ady, go to JSON Online Editor and just drop this file on it. For example, in my case, I had 10 channels, 5.1.4, and for each channel, front left, response data, I will see only 3 measurements because I took only 3 measurements, each with 16,384 data points. Then go to the Excel file I will provide you with. There is a perfect impulse response here called Dirac pulse in pretty JSON format, the 1 followed by zeros all the way, 16,384 of them. Copy that and go to response data 0 for front left and Ctrl V, paste. Response data 1, Ctrl V. Response data 2, Ctrl V. Front left is finished. Go to center speaker, response data 0, paste. Response data 1, paste. You have to do this for every response data of every channel, including the subwoofer channel here. Response data, paste. You can use a Python script to do that very quickly if you have Python installed, but you will do it only once and it doesn't take really long. This is the mathematically perfect impulse response, and the idea is to stop Audyssey from applying any correction to speakers by cheating it into all speakers having perfect responses. When finished, save and transfer the revised ADY to your phone app and then send it to your AVR. Here I named it default.ady. You have to first transfer this to your phone, then send it to your AVR. When you see the transfer is complete message in your MultEQ Editor app on the phone, now it's time to go to your receivers menu. I will use the web interface, which is much easier. You can use this only by changing your IP address. Your receiver will have a different one in your network. The rest is the same. This perfect impulse Audyssey correction comes with, in fact, no correction, but certain settings. MultEQ XT32 reference, dynamic EQ on, reference level offset 0. Dynamic volume may come on if you didn't change it in the app, but it should be off. Actually, it doesn't even matter, but just keep it off. And Audyssey LFC by default is off anyway. For the speakers, it comes with all levels set to 0, all distances set to 0.04 meters, and all speakers set to large because they are perfect speakers. One more adjustment you need to do in audio under surround parameter. Low frequency effects, you have to change this to -10 dB because Dolby Atmos LFE channel is boosted by 10 dB. To measure your subwoofer level correctly, you need to do that, but don't forget to change it back to 0 dB after you complete the calibration. With this setting, the subwoofer, when measured on its own through LFE channel, will give you the correct SPL level. You have to set the volume level to the maximum level you listen to your system, because we will tune the system, including surround speakers, to give the perfect target response at that level with dynamic EQ on. For levels below that, the EQ will correctly apply some boost to bass and high frequency, replicating the so-called EQ loudness contours, and you will be able to adjust the strength of that to your taste by changing the reference level offset here, because from 10 dB you can go up or down to 5 or 15. That is the reason I picked 10 dB. The maximum level I watch movies is -24.5 dBFS. To set receiver's volume to that, I will use control protocols. Again, the IP address will be different for you, but the rest is the same. 8080 go for my phone app direct XML, and after the question mark you give the command as in control protocol. There's a long list of control protocols available from Denon, same with Marantz. I will give you a link for that in the description section of the video. This is, for example, master volume 55. The scale is different, but this sets my receiver volume to -24.5 dBFS, which is around 75 dB. Also, don't forget to set your subwoofer power settings to permanently on, not auto, during calibration. It happened a couple of times to me that when I'm measuring a speaker with crossover active, one of the subwoofers switched to standby mode and you only measure with one subwoofer. Bass response is wrong. It can become very confusing. Better set them on during the calibration. Now it's measurement time. Before we set REW for measurements, you may try just a single central point measurement or take multiple microphone position measurements. Multiple mic position measurements will remove the local dips, consequently avoid the boosts we will need to apply to such dips, which is a more robust way of correcting a speaker's impulse response. For multiple measurements, try to keep microphone positions symmetrical around the central listening position so the averages make better sense, and take the central listening position measurement the last so that you can keep the microphone there, as you will need to repeat many measurements at that point for speaker level distance and crossover adjustments. Now we can go over the REW settings that you should be applying before taking measurements. Say no to this because this is at the moment asking for Java. Don't show this message again. This is a reset REW, so you can see every setting that is not default. So preferences, sound card, drivers, ASIO for all. You have to install that if you don't have that. ASIO control panel. My UMic 2 microphone is already there, but I'm not gonna use anything Realtek. And here is, I think, the Marantz receiver, so I have to turn this on as well and reload. And I see the play signs at the correct places, so this is done. Output 1 for front left channel. Timing reference output, I choose center speaker because it's the easiest one to measure the distance of to the central listening position, to the microphone position. In this tutorial we will manually adjust the distances. UMic 1, and now it's the correct AS via calibration. You have to upload here the 90 degree, it's not stereo mono, 90 degree one for your microphone, because it's going to be pointing up. If you were using the Audyssey microphone, here is the calibration file for it, which I will also provide to you. Here, Audyssey microphone would be probably connected to your mic input from Realtek, so you would select this and reload, and also choose that calibration file. Then you can take measurements just like you do with the UMic. Main speaker test signal here. Calibration files. The 90 degree calibration file is there. The non-pink ones are not valid anyway. We don't have a sound card. Comms, you don't need to enable MIDI. You don't have a MIDI output port. No house curve necessary. Analysis here, add frequency dependent window, 15 cycles default, and no smoothing will be changed, psychoacoustic smoothing. Adjust clock with acoustic reference should be ticked, and it's ticked by default. You can untick this one because we are not going to be using a sound card. That is all here. Equalizer, target type, none, and here the house curve that you have to apply, change high frequency fall to 200 Hz, and at 10 Hz, and the slopes 0.7 for both. This is a Harman curve. Here you will really benefit from increasing the number of measurements to 100 minimum. It can go up to 199, but your memory will run out before that, so 100 is good. You will quickly use 100 when you're doing 9.1.6 measurements. And you have to restart REW for that. Everything else can be the same. Reopen REW with 100 measurements capacity. I will not do all the measurements. There are 10 of them. Each location I measured to the left of the central position, right of the central position, and central position. Only 3 locations. Even that is like 30 measurements. But I will show you how to measure the height speakers and how to switch between revved plate files versus its own generated sweeps. When initially your ASIO control is in your receiver here, okay? So when you select measure, the measurements should be 0 to 24,000. Acoustic timing reference here should be selected. Reference output, a speaker of your choice. I choose my center speaker, which is number 3, because I can calculate the distance to it. The important thing is that you should not change this reference speaker throughout the calibration. Whichever you pick, it's not that important. So this is now from REW, okay? I will show you that they have no difference between the plate files and these files. So let's measure the front left speaker, which is number 1. Length will be 128K. You can thank Todd Song of AV Nirvana for that. He prepared the shortest files for us. They are still a lot more detailed than Audyssey's own measurements, so no worries there, and it's a lot quicker to measure. Now I'm starting. Everything is correct, yes. all speakers are at large, so there is no subwoofer interaction. Front left speaker from Rev's original. Now let's try measuring it with the plate files that I will provide you. You have to browse and go to Atmos sweeps, and this one file here you should upload to REW. It's the only WAV file among all the other files. The others are MP4. This is how REW knows what kind of sweep to expect, and after that you just start and it will wait for the signal. Now you can play, but it's not gonna work because the ASIO is still controlled by REW, Atmos sweeps, and front left. Let's find it here, this one, play it. So there's a problem. I did that on purpose because first you have to go to preferences, ASIO control panel, and tick that, see this message, now ASIO driver is released. Now you can start the measurement. It's gonna start waiting for the chirp, so it won't measure anything. While it's waiting, you can just start the plate file. And now it heard the timing reference and it measures. It's identical. These are just my speech, I think, here. So the plate files and Rev generated files make no difference at all, except for the LFE channel, because ThoughtZone creates them very complicated way with Amazon Web Services, Dolby Atmos encoders, and LFE is encoded at 120 Hz cutoff by standard. Only different file, the levels, everything will be the same, timing will be the same, so you can use whichever. Obviously for high channels, you have only the option of plate files. Rev cannot generate these, but can generate the floor channels 7.1. Here you have all the 16 channels along with the base file that you should upload. So with the sub channel, the only difference, for many of you it won't make a difference, you can just as well always use the plate files and even use LFE, but let's measure LFE from the plate files. Again, press start, and this time just play LFE. Now let's play LFE from REW original sweep. As you see, it's not connected because we disconnected it. You have to go to preferences again, ASIO control panel, and just turn this back on. See this message? That's it, close that. And now measure from REW, choose output. The play sign didn't come up here. The reason being, Windows Media Player still open. You have to close it because this is still holding the ASIO driver. Once you close Windows Media Player and reload, you will see that the sign is there. This is the problem that you can face while switching between played and generated sweeps, and this is how to solve it. From now on, it will play subwoofer channel, which is channel 4. Start. As you see, at 120, LFE channel has a low pass filter. The normal REW file doesn't have, so my subwoofers go all the way up to 150s, which I need because I'm using very small satellite speakers. But for many who will not use anything above 120 crossover, plate file is good enough. That's the only difference. If you want frequencies over 120 from your subwoofer, you have to play it from Rev part here, or else you can go to from file at the beginning and never even use from Rev until the end of the calibration. I have showed you now in detail how to switch between played and generated sweeps and how to take measurements, how to switch ASIO drivers. The only other thing I can tell you is sometimes if the media player is not producing the correct channels, you have to check that the playback, your Marantz or Denon receiver is the default device. If it's not, sometimes top rear left channel can play from the front left speaker. A lot of people complain that they can only get stereo. This is the reason. There can't be any other reason if your drivers are properly set. Now I will upload my already measured data and we will continue from that. As you see, there's quite a bit of measurements done. And this is only for 3 microphone points. The number ones, front left one, front right one, center one, subwoofer one, are to the left of the central listening position, about 20 centimeters in my case. All the number 2 measurements, FL2, FR2, C2, going on all the way to top rear right 2, are same distance from the central position. to the right. The microphone is on the right of the central listening position, and I measured all the speakers there. And the last one is the central one, which I called FL0, FR0, all the speakers that I have at the central listening position. And the microphone is still standing there at the same position, so I can keep taking more measurements if I need to. We have to first cross-correlation align the measurements to each other, because cross-correlation align prioritizes the one on the top of the other measurements as the original measurement. So you have to carry up the ones with 0 in this. The last measurement at the central listening position have to be on top of FL1 and 2. This is the only way, manually carrying them on one by one. Subwoofer 0 goes above every other subwoofer measurement. And top rear right, finally. Now to cross-correlation align, go to all SPL tab, unselect everything to align front left speakers. FL0, FL1, and FL2 should be selected. Because FL0 is on top of FL1 and FL2, when you do cross-correlation align from controls here, it will time align FL2 and FL1 to the time alignment of FL0, which is the central location. Okay, and you can watch what's happening, and you have to, sorry, before you do that, the new rave feature, copy selections to other overlay graphs, so that you don't have to deal with unselecting everything, and go to impulse response, change this to percentage from dBFS, and zoom in. Let's make this visually, and they're all the same red color, interestingly. Here are my chirps because of crosstalk in my system, but I'm not gonna be using them this time to measure speaker distances, so don't worry if you don't see the chirps. Now the one in the middle is front left, and the one on the left, this is FL1, somewhere around 22 centimeters to the left of the center's position, and the one on the right is somewhere around, again, very similar, 23. This doesn't have to be exactly the same, but it should be kind of symmetrical for the average responses to make more sense in the later stages of the correction. So you keep this on site. Show points when zoomed in is a very useful feature. You have to tick that. When it is large enough, you can see all the measurement points. And that will help you when to end cross correlation. In this small screen, it's not going to be easy. Yeah, now I can. And let's minimize REW so you can see both screens at once. Okay, now again, FL0 selected on top of every other, and FL1 and FL2 selected. I'll show you only front left speaker cross correlation alignment. You have to do this for every speaker. Click cross correlation align once and watch the overlay screen here. Move these two on top of this one. Unfortunately, they're all red. The moving doesn't stop. You have to click it a couple of more times until you see the dots not moving at all. One more time. See, there's a little bit more movement. One more time. Still some movement. And the dots, just chase these dots. One more time. One more time. You cannot overpress it, so press as many times as you like. As you see, it's not moving anymore, so it's properly aligned. These are our three different front left measurements, different to each other, but time aligned perfectly here. Okay, do this for FR0, C0, subwoofer, surround left, surround right, top front left, top front right, top rear right, top rear left. This should be over this one. Yeah, just for the sake of it. After you align all these, you will create a copy of FL0, the ones with the 0 indices, the central listening position measurements. Let me do it only for front left speaker. Just create a copy of front left from controls, measurement actions, and response copy. So you have FL0 copy. All of them are selected on all SPL screen, FL0, FL1, FL2, and FL0 copy. Now vector average them. The idea here is to give more weighted average to the central listening position measurement. This is your front left. This is the measurement that you will be using to correct your speaker response. You have to do that for every other speaker, needless to say. And after that, you can delete every other measurement. Just leave FL, FR, C, etc., whichever speakers you have. And these are the measurements you will be working with. Now I'm gonna switch to the measurement group that I have already done this, so we can continue from there. Okay, here are my all channels averaged. Now we will have to determine the speaker distances. Overlays. Here are the impulses of all these speakers. As you see, I still have the chirps, and I can very easily just find out my front left speaker actual distance by drawing this line with Control and mouse right key, and it's at 2 meters 77 centimeters, which is quite correct, actually very correct. And my center speaker is with its chirp only heads up, so I will calculate from top to top. It's 3.01 meters. Okay, but let's assume you don't have crosstalk in your system, unlike mine, and you cannot see the chirp like many of you out there. Then you have to, the center channel is my acoustic reference channel. That's why its impulse peak is always on time 0. As you see, every speaker is deviated, but center speaker, being the acoustic reference, is always going to be time 0, no matter what distance you enter here. So you measured your center speaker distance to the tip of the microphone, and you found it 3.00 instead of 3.01. You could find it 2.95, but for ease of calculations, because we're gonna use this 3 meter quite a bit, so you didn't accurately enter this, doesn't matter, just set the distance. So now center speaker is at 3 meters. From here on, to correctly find out the speaker distances, you just measure their distance to center speaker. And then you will have to deduct it for the speed of sound error in these receivers. A lot of people are struggling between 0.88235 or 0.87463. I'll save you from all of that, because you will go to Preferences, View, and change speed of sound here from 343 to 300. Now you can just enter the distance you see directly into your amplifier. Now let's check my front left speaker distance, some better visuals. The distance from tip of it to impulse peak of it to the impulse peak of the center speaker is 0.211 meters, and it is arriving earlier than center speaker. So center speaker was at 3 meters. All you have to do is open up a calculator. 3 minus 0.211. 2.79 is what you have to enter to front speaker distance. Set. And when you now remeasure front left from file, obviously, you can measure it from REW just as well, but I don't want to switch ASIO drivers right now. Start. And the new front left is right on top of center speaker. There will be a slight difference, and you cannot fix that. These receivers are not capable of. You can check for inaccuracy. If it is below 3 centimeters, forget it. It is just 0.1 centimeter. This is how you fix your speaker distances. You can do this for every speaker. Top, front, left, and center. All you gotta do is the distance, 0.35. So you go again to calculator, 3.00 minus 0.358. So 2.64 is your top front left speaker distance. Top front left is 2.64. Set. Now you can measure and test. Here is the top front left measurement, right on top of center. When you do this way, you will almost instantly get them right. As you see, the difference is 0.3 centimeters, which we cannot change. You can't change this better than 3-4 centimeters. Although in the receiver settings, it looks like it is 1 centimeter accurate. It's not, as I have mentioned in my previous videos many times before. Let's finally do subwoofer, because it might be sometimes harder to find. Then you can do the rest, I believe. So overlay, subwoofer, and center. Subwoofer impulse peak to the center speaker's impulse peak, and because of this line here you can't read the number, so I redo it. It's not accurate enough. Because if you get it accurate enough here, then you don't have to remeasure and realign and remeasure. Okay, it's 3.967 meters. This time subwoofer is arriving later than the center speaker. It's on the right of it, okay? This is time 0. The subwoofer is arriving 12 microseconds later than center speaker. So we have to add this difference to center speaker. 3 plus 3.967. So 6.97 meters is my subwoofer distance. What was the number? 6.97. It's not gonna let us enter that. The reason being, it cannot be more than 6 meters more than the other speakers. So because these are still 0, it will not accept 6.97 yet. As you see, it will accept only 5, maybe 6, yes, and then you increase. After 6.40 something, it defaults to 0. So to change that, I will randomly increase these speaker distances. Now it will accept, I think, 6.97. No, it's still not accepting. Oh, because this is still 0. 3 meters. Okay, 6.97. And set. And now remeasure your subwoofer, for which we will have to switch players. Or actually, no. I think the impulse peak will not make a difference. There is a low pass filter on the Audiophile channel here. I'm hoping the impulse peaks are the same. Well, not really. Almost-ish. The impulse peak of this, because it has a crossover, is different, I guess. So we'll have to measure this properly. Put the ASIO drivers back, close Windows Media Player, reload, so you get rid of this red cross sign there, and then measure sub from REW. Yeah. This is now perfectly aligned subwoofer with the rest of the system. So that's all for speaker distance settings. Now we have to align the volume levels of all speakers. This is pre-correction volume levels, so that you don't have to correct too much. It doesn't need to be very accurate, but it's good to align them before inverting them. Get rid of all these impulse peak responses. First, create copies of every measurement. FL response copy, FR response copy, C response copy, subwoofer you don't need, SL response copy, and DRR. Now select only the copies. Except for the subwoofer, everything is selected. Then align SPL 1001 kilohertz, 5 octaves, that is 2.5 octaves to the left of 1000 and 2.5 octaves to the right of 1000, covering around 200 hertz up to something like 5000 hertz. And they are now aligned from 1k hertz around this area. Volume aligned. Now we have to check how much alignment was really applied to each speaker, and to the best of the accuracy in the receiver we have to move the speaker responses accordingly. Take FL and FL copy, select FL here and give it the offset that it needs to come exactly onto FL copy. So it's something like 1, exactly 1, which means you have to drop front left level. Sorry, this should be 0 again. -1 for front left set. Now do the same for front right. Take only front right and front right copy, select front right. I forgot to add offset to data this, don't forget that. So FR needs again 1.1 dB, but we don't have that. It should be multiples of 0.5, so 1, and add offset to data. Again, for FR, give a 1 dB negative SPL offset. Do the same for all speakers. Center. Center, we have to increase the volume about 2.6, which is 2.5, the closest to that. So center increases by 2.5. By that way you have to align all the speakers, then you can delete all the copies, and these are gonna be the final responses that you will correct then at the Audyssey Curve Edit points. Now I'm gonna load the already SPL aligned measurements so we don't lose more time. Now everything is SPL aligned except for the subwoofer, and these were the settings I had to dial in. Top rear right didn't need any SPL change, but this is the default. They are most equal with these values before calibration. And now for the subwoofer we untick that, and when every speaker response is on the screen except for the sub, we take an RMS average, root mean square average. And with this root mean square average, which is here, we go to EQ and target settings, add room curve, the room curve with these values that you already selected in preferences tab, calculate target level from response. And once it does that, it decided the dB level is 70.9 and generate measurement from target shape. So you have this target on your all SPL screen. You can now get rid of RMS average. Now untick everything again, target and subwoofer. This is how you adjust the volume of subwoofer. Select subwoofer here, and this is before correction. I think something like that it should be, so it's this much boosted here, around 4 dB, and there is a dip here around 4 dB. But you can't give it a 4.3 negative SPL. It should be either 4.5 or 4. I think 4.5 makes more sense. So you go to subwoofer SPL and negative 4.5 set and add offset to data for this one. Now everything is aligned. Now the correction process. For each speaker, you have to go to trace arithmetic, target. Let's just call this target. The name RMS average one is a bit annoying. Okay, target divided, but magnitude division, absolute value division, not A over B. This one, but this one. This is a new rev feature. Before that, you had to do 2 divisions to get there. This is much easier. Regularization 0, nothing ticked, generate. And if you look at 0 dB level, you now have the inverted response for the front left speaker, which is here. This is target. We inverted it over the target curve. Okay, you have to do that for every speaker. Target over FR, target over C, subwoofer, surround left, surround right, top front left, top front right, top rear left, top rear right. Don't forget to name them or you're gonna get very confused very quickly. We call this FL correction or inverted, whichever you prefer. FRC, CC, subwoofer C, SLC, SRC. If you're confused, you can see here what division it was. This was target over SR, so it's SRC. This is target over TFL, so it's TFLC for correction. Now, again, clear selections. Select all the correction responses. Except for the subwoofer. This is an easier way to do that. Once they are selected on screen, go to export as text. Use custom range 20 to 20,000. Use custom resolution 24 PPO. Use smoothing of measurement psychoacoustic. These are okay. Don't include any commands or headers in the export. This is irrelevant. We are not doing multi-input capture, but untick it anyways. When you say okay, it's gonna ask you for a folder. Let's go to our famous Supreme Audyssey folder and select. It's done now. All of them at once are written here, probably, as you see. We didn't export subwoofer yet. Go to subwoofer. This time just one export, so you can do it from here. Export measurement as text. Custom range 20 to 250. Rest is the same. And it should be in this folder. Name is SC. Save. Now you have all of the correction filters, let's say. We're gonna convert this into curve edit points. I will do for front left. When you double click, automatically opens in Notepad. Okay. Control A for select all and Control C for copy. You copied all of the values. Go to your Excel file, the same Excel file we opened in the beginning of the tutorial, Audyssey Curve Editor. Here you paste it like that. For the first paste, you have to do data, text the columns, next, untick tab and click space and finish. Yes. So it separates the numbers just for the first one. For the rest of the paste, you don't have to do that again. And automatically it will give you what you need to copy to the curve editor. Just select them all. Control C. JSON editor, if it's still there, of course it's not. Your default file that you have sent to your receiver after making it a correct response, put it back. This one with detected channels of only direct responses. So this was front left. Go to front left custom curve points. Click one more time. Control V for paste. And 241 items, you're done. Now do this for the second one, which is center channel. Again, double click, you can close this notepad, double click center channel collection, Ctrl A, Ctrl C, Excel, go to the beginning, Ctrl V, and select them, Ctrl C, and JSON, and click one more time, click and Ctrl V. And this is your center channel. Now front right. So you do this for every channel, including the subwoofer. Let's do subwoofer because it has less data points. It's the same thing, but just in case. Ctrl A, Ctrl C, Excel. Do the subwoofer last for the simple reason that it has much less data points, which means you have to end the data here with this square bracket, and this one shouldn't have a comma. Just delete this comma here. Now copy these and paste it to subwoofer. Custom curve edit points. 88 items. Once you do all this, again save it and send it to your app, and from the app send it to your AVR, and then I will meet you at that point again. Okay, I hope it's not too late to tell you this, but before you send the new revised and curve edit point ADY file to your AVR, take a photo of all speaker distances and speaker levels that you have changed in the AVR, because once you send it, this is what's going to happen again. Distances will be reset to 0.04 and levels will be all reset to 0. Just take a note or take a photo, and when you're here, put them back in. Like so. This was -4. I'm now checking from a photo on my phone. This was -4.5, -3. So you do all this and then set and go to distances and enter your distances correctly. This one was 2.79, center was 3, subwoofer was 6.97. You have to put them back and also go to audio, Audyssey, dynamic EQ on reference, and this is 10 dB again. Because now you have to remeasure every speaker, now that they are supposed to be corrected, and they will be. Let's try a couple of them. I will do from REW sweeps, reload, measure run for the front left. The important point is that the microphone doesn't move and the receiver volume doesn't change throughout the calibration. I remind you one more time. This is our front left. It's almost a smooth flat line. And front right. And surround right. I won't do the ceiling speakers for now. Okay, front right, center, sub, SL and SR. We have a huge boost in the surround left because my levels are not properly adjusted. This is quite unexpected. Of course, surround left has been left at 0, that's why. Anyway, for illustration purposes, now what you do at this stage is before you determine the crossovers, you have to level them one more time. They will probably be almost level, but you might have 0.5 to 1 dB differences due to the correction applied. Okay, so you have to double check. You can do the same align SPL method by creating copies of this, or you can use the Atmos video that I will provide here, Dolby test tones. 9.1.6 channel Dolby test tones, and it's pink noise covering all the frequency range from 0 to 24,000, which is very convenient because REW's pink noise at check levels only covers from 500 to 2000. This is full range. Plays every speaker in the system for 1 minute for a total of 60 minutes. You have to skip to change speakers. But 1 minute is long enough to calibrate whatever you want. And how you calibrate, by the way, is through SPL meter of REW. As you see, it's showing the dB level for the subwoofer right now. And now it's showing the dB level for a speaker I don't have. Yeah, this is what I have. So from here also you can see pretty much full range level. You should maybe do this after crossing over with the subwoofers. It will be even more accurate, because it will really be what this speaker is capable of at the current correction and crossover in terms of all frequencies. Or you can, as I said, just use align SPL method. With this one you have the flexibility to align them to wherever you want. Like if you align them for, let's say, 200 Hertz by just 2 octaves, this is gonna be all speech. Male and female voices will all be covered, because this is gonna align them from 100 to 400 Hertz. So you're flexible, and after correction they will come almost equal anyways. Look at the volumes of these things. You can see here that they are quite equal. Maybe half a dB or something. Now the more important point, how to determine the crossover rates. Let me just adjust this SL like we correctly measured it when the levels were fine. Sorry, not this one. Pull it back. Even this one might need a 0.5 dB negative boost. By the way, let's say we aligned that like this, and SL is aligned -4.5, no, more like 5 or 5.5, something like that, 5 dB. Add offset the data. Remove subwoofer again. You will have all the speakers here though, including your top fronts, top rears, and what have you. And then go to RMS average as usual, and go to EQ with this RMS average selected, calculate target response and generate measurement from target shape. This new target will be a couple of dB lower than your previous target, because these were applied some correction. Once you have the target there, again, you're finalizing the subwoofer level. Much prettier now. And this is what you have to apply to subwoofer for perfect response. -7 dB. You will do that here, obviously. Sorry, 7. Every change you do here, you have to apply to the receiver. After you have all the corrected and time-aligned responses, no need for RMS average. What you have to do is determine the crossover rates. Because we have no control over the phases of the speakers, Audyssey doesn't give us the opportunity to phase align anything, although it's possible with FIR filters, so the receiver is capable of it, but don't go there. And like in my system, and I'm obsessive compulsive, my left and right speakers are perfectly aligned to the central listening position, to the millimeter. But when you talk about ceiling speakers or surround backs or surround fronts, it's almost impossible that they are at exactly the equal distance to your ears, and any difference there will create very different combined phases. So crossing them over, for example, like Audyssey does, let's say this is center and this is subwoofer, and Audyssey checks for the crossing points and probably will do this at 80 if it gets it right, because there's an intersection here. This is too low and this is too high. That's what it's gonna do. In fact, it should leave this speaker as large because its bass response is better than the subwoofer, but this is not gonna be the case with you. The reason for that is I have focal air subs for focal dome flex speakers. They are really tiny, and the subwoofer is tinier than my even center speaker, as you see. But regardless, how to determine the crossover? First, the pair that you're gonna cross over, let's say you're doing the fronts, okay? You select only them, front left and front right, and take a vector average. And then this vector average with the subwoofer, merge B to A, blend. And you start from 40, generate 50, 60 after 40, it comes 60 in the crossover ranges, generate. Then there is 80, generate. Then there is 90, generate. Then there is 100, generate. Then there is 110, generate. And there is 120, generate. And there is, I think, 150. Obviously for the fronts this is meaningless going beyond 80, but suppose you're doing the Atmos speakers, this is the method. And now with everything cleaned and the target there, where's our target here, which one do you think is the correct one? It's very obviously this green one here. So you cross over your fronts at 120 Hertz. That's it, that's so simple. And go there, go to speaker configuration, change this to small, and cross over 120. Now let's do one more for the surround left and right. It'll be a bit more logical than my fronts. My fronts normally should be left alone and set at large, but I don't want to deal with their woofers. I want the bass to be managed by my subwoofers only, which has a very smooth response. There is a mini DSP working there. Anyway, surround left and surround right selected, vector average. Okay. And clear the screen. So now this vector average here with subwoofer, start merging from 150, 120, generate, 110, generate, 100, generate. You can do the same for center, no vector average required. 90, I think, 80, and ideally try to cross them all at around 80. Now there is no 70, there is 60, I think, and then there is 40. Again, put the target there. Only this red one survives and shows you that you had to cross them over at 150 Hertz. So you go and change surround to 150. That's it. What else you can do? Don't forget to put LFE level from -10 to 0 dB. I guess that's all you need to apply this method. Thanks for watching, and don't forget to give feedback about your results in the comments section. I try and respond to questions in comments quite rapidly. Also remember to check the description section under the video. You will find all the links required there, as well as information on any future updates or revisions. You might be aware that my ultimate, supreme, optimal corrections never end. Well, REW is continuously improving, so are my methods. Although this method is quite groundbreaking, I am also considering to develop a correction where only the response peaks are cut off without any boost to dips. And I already have an idea on how to do it perfectly. Very flat, perfect frequency response doesn't always mean it's the best sound possible. I have a lot of experience with stereo speakers with much accurate filters, and in fact, the less you boost the dips, the better it sounds. So I might try that on Audyssey at some point. Another option in my mind is calibrating with moving microphone measurement technique, which is known to give very good results and is suitable to Audyssey as it doesn't require or contain phase response information. Don't forget to subscribe if you want to be notified when new videos are out, and bye!